October 9th, 2013. These are Earth-facing LASCO C3 images from today and yesterday, and there's the small comet that we watched on the video. Now it's being followed from the same direction by another comet that seems to be brighter there. Now it could be just that it's a somewhat larger, or that the increased solar activity has energized it, because they are electric. Now notice this is ISON's path, so it's going to come in from that same bottom right angle and go out the top. Now you've got an overlay of both the LASCO C3 and C2 images that you see there in the red. Now the way you would determine this is, first you've got to see what is the viewing field of LASCO C3, and here it's telling you that it's from 3.5 to 30 radii. All right, that's how far that's what you see when you look at that blue camera. Now I'll break that down first to show you on the LASCO C2. That's the red camera. You're getting 6 solar radii. That's the radius of the sun. That's across there, and the red in the center there is what you would view in the red. That is 6 radii. C3 is 30 radii. Now one solar radius is 432,450 miles, and you got 0.0046 AU. You can pause this and read any of this other information you like. It just gives you some of the other details, and it's interesting to do that. We can use this information to determine the date that ISON will come into LASCO, and I'll show you how you do that. But what you got to remember, ISON's coming in from the right and leaving out of the right. So you've got to multiply 432,000 miles times 15 radii. That's where it's coming in. Is 6,486,750 miles. Remember, 6 million. All right, that's the distance that you see times 2 if you scan across the entire LASCO C3 image. 6 million, okay, at 0.5. Now, we're looking at ISON 3D. We're looking at today's date, October 9th, and it's showing, I'll spin this around, that ISON is 127 million miles from the sun. It's to the right of Mars in the night sky. Again, I think it's about a day off from the track of Stellarium. But regardless of what this model is, regardless of what ISON is, this is the only information that we can use to try to determine some of the data. So just bear with me here. It's showing November 20th, 2013, that we're going to start seeing it with the naked eye. But I'm going to pull it around here and pull it up close, and we'll see when it's coming in on LASCO. Now remember, we got 6 plus million miles that we're dealing with as far as viewable time. Now I'm going to advance this up until we get within 6 million miles of the sun. It starts moving extremely fast. Right now it's 2 million miles a day. By that time it's going to be moving at 7 million miles a day. So what does that tell you? You've got about 1 day viewing coming in and 1 day viewing going out on LASCO. And as it comes out, we're supposed to be able to see it through mid-January by the naked eye, by viewing looking straight up, eventually at Polaris. But here, and it may be hard to see, we're down to 6 million miles. That's November 27th. You see that, guys? 26. We're back out to 13. So that's 7 million miles per day as it gets that close to the sun. 27th, we're on LASCO through the 29th, and then on the 30th, it's out of LASCO. So you can determine there. Just remember, on the 27th, I would start watching on the 26th through the 27th. It's going to be coming in on the satellite like you're seeing these, but much brighter. Now, that's if it does what the charts are saying. I'm going to show you some of the newest images. And whatever ISON is several objects. If it's a comet, it's breaking apart. But it has been showing multiple objects now since May. So either it's continuing to break apart slowly, or it has been multiple objects that are still holding together. Now these are close-ups of this last comet coming in today. I just pulled them up and kind of give you an inside look. there it appears to be breaking up somewhat as it gets close. Now, will ISON continue to break up? But these are some of the newer ground-based images. They're about 24 hours old on these. And these are ISON. And I'm going to get even closer up. I just want to show you some of the different images. It's a beautiful comet, even through the different light filters. But you see that it's getting elongated and spreading out. And they said it was doing that because of the increased solar wind speed and pressure is narrowing that Coma down to around 65,000 kilometers. Again, I'm going to get it up close and we'll look at it in detail as we go through these. It's going to be amazing to watch with the naked eye. And these are just different filters, but bear with me here a moment. Now, this is as close as you can get at the present time at looking inside this comet without using Hubble, which they're not going to let us see. But we got 3 objects at least in that front. Then we're counting 5 more that's been spread out, elongated through this comet body. Now that's, you're counting 5 in the back plus that front. Now I'm going to pull that front up and show you that that section appears to be at least 3 objects. And you can dim it down and go in and out as far as you want to, and that's about what it appears to be. So we may have a total of 8 objects, and the smallest ones would not be picking up here. And we don't know if ISON is throwing out any comets in front of it. We've seen that happen before. There were 2 that dove in before Comet Lovejoy, guys. But it's a heads up on this. Be safe.